Hello everyone. I welcome you all to our today's presentation titled as Too Close for Comfort: Morasses of Anti-Censorship in the Era of CDNs. My name is Devashish Gosai, and this work was in joint collaboration with my colleagues Mayank Mohindra and Sambodha Chakravarti at IIIT Delhi, India. Internet censorship has always been a point of concern for free speech activists. This is because it is the control of what information can be accessed, published, or viewed in the internet, typically by nation states or governments. As can be seen in this figure, almost all countries engage in some form of filtering or surveillance across the globe. Thus, various popular circumvention systems have been proposed, popular ones being Tor and VPN. However, these proxy-based solutions face cat and mouse game. As soon as the IP address of the proxy becomes common knowledge, it is simply blocked. Thus, various newer anti-censorship solutions have been proposed that aim to end this censorship arms race, for example, decoy routing. But these newer solutions assume that a popular web content is hosted outside the censor's purview for their successful work. If we talk about popular web content, for example, Alexa websites, CDNs comes into the picture. In last 2 decades, there has been a rampant growth of CDNs over the internet. And thus, Alexa websites are replicated across multiple geographic locations called as frontends. As can be seen in this figure, clients in the different parts of the globe, rather than communicating with the parent website, ends up in communicating with the frontends likely located near them within their own countries. Thus, popular web content, example Alexa websites, are likely proximus to clients' geolocation. If this is the case, then various anti-censorship approaches that rely on them with the assumption that the popular content is hosted outside the census regime may get impacted due to CDN proliferation. The first one is decoy routing. In decoy routing, various entities are involved, that is, OD, over destination, set of unblocked websites that a censor is not willing to block, covert destination, that is, those websites that a censor is willing to block, and a friendly ISP that hosts a DR outside the censor's regime. It is a special router that is going to be different from the normal router in its working. It is further assumed that a client is going to send a specially crafted web request that would be intercepted by the router when it would be going towards the OD. The DR would understand that though it is destined to OD, the intent is to communicate with CD. And thus, DR with the help of DR proxy fetches the content from CD and sends it back to the client, spoofing the source IP as of the OD. A pretense is made to the censor that the client is communicating with OD, but in practice, it was communicating with CD. If the OD is hosted within the censor's regime, the specially crafted web request would not cross the censor's boundary and would not be intercepted by the DR, and eventually decoy routing is going to be hampered. The other approaches that could be hampered are cache browser and CDN Reaper. In these approaches, it is assumed that the blocked websites, if hosted on a CDN, can be accessed via frontends located outside the censor's boundary. For example, if a client is hosted within the censor's boundary, is located within the censor's boundary, and attempts to access a blocked website hosted on a CDN, it would likely be mapped to a frontend that is located near itself within the boundary, say with the IP address IP1. It is obvious and evident that the censor can trivially block the IP address because it is in its own regime. However, it is assumed that it is non-trivial for the adversary to enumerate all the different IP addresses associated with different frontends across the globe and would block them. Further, if the client in the census regime would communicate with its peer outside and obtain this IP address out of band, say by an email, the client in the census regime can directly communicate with the IP address and can obtain the content. But if the website is hosted on the anycasted CDN, the assumption that different frontends have different IP addresses would go, and all the frontends are going to have the same IP address. In such a scenario, client would have no option to send its traffic outside the census regime, as was the case with the previous DNS-based CDN. Thus, if a large fraction of the websites are hosted on Anycast CDNs, client cannot access foreign frontends, and the approaches cache browser and CDN Reaper would also be impacted. Further, the other approach that could be impacted is domain fronting. Domain fronting is require routing at the application layer. It assumes that different domain names can be sent at different layer of communication with the CDN frontend, and that frontend is going to understand that though the client is sending different domain name, its intent is to actually fetch the forbidden.example. For example, in this figure, client would send allowed.example as a part of DNS query or TLS client hello SNI field, and to a sensor it would appear that client is communicating with allowed.example as these two fields are in plain text. Once the secure channel is established, client is going to send its real intent of forbidden.example in an encrypted packet. The domain fronting supported CDN frontend would understand and would reply with the forbidden.examples content. But if the CDN frontend is located within the sensor, again, the sensor can coerce a CDN provider to abandon its use. It is already alleged that Roskomnadzor, the nodal agency in Russia for controlling the information within the country, has coerced some giant companies that were supporting domain fronting, and as a consequence of coercion, the domain fronting has been abandoned. Further, the approaches like covert cast could also be impacted. In this approach, it is assumed that the content of the blocked website is transported via real-time encrypted video streaming services like YouTube. But if the YouTube frontends are located within the sensor can coerce the YouTube to stop its use. This has already been acknowledged by the authors in the paper of covert cast. If there are enough newer anti-censorship solutions that actually depends on the popular websites, we asked this question whether the websites are hosted within or outside the census regime. And for that, we assumed Alexa top websites as the popular ones. We resolved the websites and identified their IP addresses and eventually predicted whether they are inside or outside. And to geolocate these websites, broadly, there are two approaches. Passive ones that rely on database lookup, but they are known to errors. And the other ones are active methods that we used, and the popular one is multilateration. In this, the position of the target host, whose geolocation is not known, is estimated using distance measurements from the sufficient number of fixed reference points. For example, in this diagram, L1, L2, and L3 are landmark nodes or the reference node whose geolocation is already known to us. We are interested in geolocating the target IP tau. The process is very simple. At a very high level, L1 will try to estimate the one-way delay to tau using ping, and then it would multiply the OWD with a speed of light constraint, so 2/3 c, and would obtain a radius and would construct a circle on the world map where it would assume that the target would be located anywhere within it. The same process would be followed by other landmark nodes, and the intersection point of all the circles should ideally be the position where the target is located. But in practice, we cannot always get the precise OWD, and very likely we'll get a higher value of OWD because of congestion and various network factors. And as a consequence, we'll end up in having a larger radius and a bigger circle. And rather than having an intersection point, we end up with an intersection region, and the centroid of this region is assumed to be the target tau. However, in 2017, previous authors demonstrated that even CBG can result in large errors up to 4,000 to 5,000 kilometers in extreme cases. They concluded that closer the landmark nodes, better the accuracy. Thus, we adapted CBG for our use case and called it as RCBG. The goal of the RCBG is to identify whether a given IP address is located inside or outside the nation. We selected landmark nodes within the said country because we assume that the target IP addresses of Alexa websites are going to be likely within the nation because of CDN proliferation, and thus landmarks could be closer to them. If this is not the case and they're located outside, we handle that case as well, that I'm going to discuss in the subsequent slides. Notably, rather than predicting the exact lat long coordinates of the IP address, we used multilateration just to predict whether the IP is located in or out of the said country. We relied on 4 heuristics. The first 2 predicts the target to be inside, and the latter 2 predicts the target to be outside. For example, in this figure, different landmark nodes are represented as circles, and the target IP is represented as cross. The circles are going to intersect, and the intersection region is going to be formed within the country if the target IP is located within. However, if the intersection region is somewhat within and somewhat outside, but major part of the intersection is within, and the centroid also lies within, it is obvious that we are going to predict that the target is located within the country because it has a higher likelihood as most of the region is within the country. But if the target IP is located outside the country, say somewhere here, we'll end up with having larger values of radius and bigger circles. And as a consequence, that the intersection region is going to be formed, is going to subsume the entire country. And thus we predict the target IP to be out. But again, if the intersection region is somewhere within and somewhere outside, but most of the region is outside and the centroid is also outside, we predict the target IP to be out. Just to summarize, for the first 2 conditions, RCBG predicts target as inside, and for the latter 2 conditions, it predicts the target to be outside. We used RIPE Atlas probes as the landmark nodes. Using them, we predicted the top 5,000 country specific websites to be in or out, and we did this for 5 different countries: India, Iran, Saudi Arabia, Brazil, and USA, as we believe they represent diverse set of in terms of internet penetration and censorship levels. Before directly applying RCBG to estimate the positions of country-specific Alexa websites, we calculated its accuracy. As can be seen in this table, most of the nodes that were located inside were predicted as in, and the ones that were located outside were predicted as out. And this was applicable for all the different countries. We selected RIPE probes with known location as targets as a ground truth and other RIPE probes as our landmark nodes. And we obtained this set of accuracy. After obtaining the decent accuracy, we used RCBG and predicted the locality of Alexa top 5,000 websites. And we observed a large fraction of the Alexa top websites to be located inside the country. And thus, we likely conclude that these traffic localization because of CDN proliferation can inadvertently impact various anti-censorship approaches. We even went a step ahead and we further classified whether these websites are located on CDN or is on non-CDN infrastructure, that is simply a single hosted server. And if it is a CDN, it is DNS based or it is Anycast based. As can be seen, most of the websites that are located inside are either Anycasted or non-CDN. And the ones that are hosted outside are and are also DNS based are very less than 7%. And thus we say that cache browser and CDN Reaper might not be used as they assume that the website should be hosted on DNS based CDNs and likely outside. How we identify the type of CDNs and we classified the websites, we urge the listeners to read our paper and find this in detail there. Eventually, we also took a closer look at the notion of nation state hegemony. That is, previous authors reported a large fraction of internet paths to Alexa top 1000 websites originating from underserved countries either transit or end in powerful countries like US. However, our results paint a different picture. Most of the Alexa top of 1000 websites are hosted within the countries, and even the traceroute paths to them also remain localized within the countries. We believe that we obtain a different picture because previous authors used MaxMind for IP geolocation that is known for its inconsistencies, whereas we used multiliteration and attempted to reduce the geolocation errors to our best. Thus, we recommend that the clients must be made aware of those popular websites that are hosted outside for circumvention. And importantly, this set should be monitored periodically as popular websites are being migrated to CDNs day by day. And we believe in future we'll have a even lesser set of Alexa popular websites that are going to be hosted within the census regime. Finally, I would like to conclude by saying a large fraction of popular websites are hosted within the country and thus cannot be directly used for decoy routing. And importantly, other schemes like domain fronting and covert cast could also be hampered as censors can simply coerce the seeding providers to abandon its use. Eventually, we end up with a new dilemma. Traditional solutions are relatively easy to block based on the IP addresses, whereas newer solutions might not work due to the proliferation of CDNs. With this, I would like to end my presentation and thank you.